This video demonstrates the AOAC 980.02 method for determining gravimetric sulfur in fertilizer materials. Sulfur is an essential plant macronutrient. The only plant available form of sulfur is sulfate. However, various types of sulfur can be applied as a fertilizer, such as sulfate-sulfur and elemental sulfur. Other fertilizer sulfur sources must undergo oxidation to sulfate in the soil before becoming plant available. Supplemental addition of sulfur is becoming increasingly common due to the removal of sulfur from coal and diesel emissions. Sulfate-sulfur is sometimes also referred to as combined sulfur, since sulfate is often combined with other nutrients, such as ammonia, calcium, magnesium, and other nutrients or elements. Elemental sulfur is sometimes also referred to as free sulfur, since it's not combined with anything other than itself, and is therefore free of any other nutrients or elements. The gravimetric sulfur method is a two-part two-day method. Part 1 is the determination of sulfate-sulfur. Part 2 is the determination of elemental sulfur. Separation of these two forms of sulfur is created by the solution in diluted hydrochloric acid. Sulfate-sulfur is soluble in hydrochloric acid solution. Addition of barium results in the formation of a barium sulfate precipitate, which can be measured gravimetrically. Elemental sulfur is insoluble in hydrochloric acid solution. Elemental sulfur is removed from the acid digest by filtration. The filtered residue containing elemental sulfur is first washed with sulfur-saturated acetone to remove all organics that could be rinsed by carbon disulfide without removing sulfur. Carbon disulfide is then used to dissolve and remove elemental sulfur. Because elemental sulfur and carbon disulfide are both similar nonpolar substances, elemental sulfur is soluble in carbon disulfide. The difference between the initial residue weight and the final carbon disulfide washed residue weight is attributed to the removal of elemental sulfur. The scope of this method applies to all fertilizers, including elemental sulfur and sulfate-sulfur for both solid and liquid fertilizer products. This table is showing common sulfur-containing fertilizers. Solid fertilizers are digested with diluted hydrochloric acid and filtered. The filtrate contains sulfate-sulfur, which is precipitated with barium chloride, filtered, dried, and weighed. The insoluble portion of the original digest is used to determine elemental sulfur. This is done by weighing the residue before and after a carbon disulfide wash, which dissolves elemental sulfur. Total sulfur is defined as the sum of sulfate and elemental sulfur. For liquid fertilizers, it is assumed that no elemental sulfur is present, and total sulfur is defined as sulfate-sulfur. For 90 and 40% guaranteed products, assume all sulfur is present as elemental and escaped HCl digestion, and total sulfur is defined as elemental sulfur. These are the list of reagents and apparatus needed for the gravimetric sulfur analysis. This flowchart is illustrating the recommended workflow for a typical two-day gravimetric sulfur analysis. Day 1 includes sample weighing, preparation of sulfate leachate, and elemental sulfur residue. Day 2 includes performing the filtration of sulfate precipitate and elemental sulfur analysis using carbon disulfide wash. If only elemental sulfur analysis is required, no sulfate analysis is needed. If liquid fertilizers are analyzed, add 50% sodium hydroxide and 30% hydrogen peroxide prior to acid digestion according to the instructions here. This is done to oxidize sulfur to sulfate prior to precipitation step. Proceed with barium precipitation procedure. Total sulfur is defined as sulfate-sulfur, therefore, no elemental sulfur analysis is needed. Now we're going to demonstrate the laboratory analytical procedures using 3 different sample matrices: dry solid, liquid, and elemental sulfur. We solid liquid samples into 400 ml beakers, with elemental sulfur directly into gauge crucible with filters. Recommended weight ranges are shown in the table below. For dry solid fertilizers with guarantee 30% or less, first add 200 ml DI water with graduated cylinder. Add 15 ml concentrated hydrochloric acid. Place the beakers on the hot plate to boil samples for 10 minutes. Then filter through gauge crucible number 1 and vacuum into a 500 ml alum air. Rinse beakers with DI water to remove all residue. Elemental sulfur residue is remained in crucible number 1. Return the sulfate filtrate from vacuum flask back into 400 ml beaker. Heat nearly to boiling on hot plate. For liquid fertilizers, add 50 ml DI water, 2 ml 50% sodium hydroxide, 2 ml 30% hydrogen peroxide. Cover with watch glass and heat 1 hour. Add 3 1 ml increments of 30% hydrogen peroxide as reaction subsides. At the end of 1 hour, wash watch glass and remove. Dilute to about 200 ml with DI water. Add 5 ml hydrochloric acid. Heat leachate to near boiling. Proceed with barium precipitation. Stir and add 15 ml barium chloride. Heat at a low temperature for an hour. Stir occasionally. Perform the same barium precipitation procedure for the liquid fertilizers. Cover with watch glass. Let stand at room temperature overnight. At day 2, dry a second set of gauge crucibles with glass fiber filter paper at 250 C for an hour. Cool 30 minutes. Weigh to 4 decimal places. Filter digest through pre-weighed gauge crucible number 2. Vacuum and wash beaker 10 times with hot water. Dry gauge crucible number 2 with residue at 250 C for an hour. Cool down the crucible and record the weight to 4 decimals. Calculate the percentage sulfate according to the equations. Elemental sulfur is determined by weighing the residue before and after a carbon disulfide wash, which dissolves elemental sulfur. For solid fertilizer samples, elemental sulfur residue remains in crucible number 1 after filtration of the acid digested at A1. For 40 and 90 guaranteed products, we elemental sulfur directly onto crucible number 1 with preloaded filter pads. Washing soluble residue from original HCl digestion with 5 10 ml portions of sulfur-saturated acetone. Dry 1 hour at 85 degrees C. Cool 20 minutes in a desiccator and weigh to 4 decimals. Include slowly add 15 ml carbon disulfide with a disposable pipette. This is equal to 6 full squirts of disposable pipette. Apply gentle vacuum so as to allow time for sulfur in the sample to dissolve. Keep crucibles in hood for 5 minutes to dissipate fumes. Dry crucible number 1 for an hour at 85 degrees C. Cool 20 minutes in a desiccator and weigh to 4 decimals. Calculate the elemental sulfur percentage according to the equation. Total sulfur is equal to sulfate-sulfur plus elemental sulfur. The following is an example of a spreadsheet calculation and quality control considerations. Finally, here are some important safety considerations and potential sources of low recoveries.